Okay, for this exponential equation, my first step is to see whether or not I have the same bases. In this case scenario, I notice that the base on the left-hand side is a 7. The base on the right-hand side is a 7 as well. So since the bases are the same, I can set the exponents equal to each other. So I have x plus 4 is equal to positive 10. I will then subtract 4 on both sides. And this will leave me with a final solution of x is equal to positive 6. Moving on to the next question, we have the following. First, we begin by asking ourselves, do we have the same bases? In this case, I have a 6 on the left. I have a 36 on the right for the bases. So I need to rewrite the bases. And I always go with the smallest base. In this case scenario, 6. So I have 6 to the power of x minus 1. That one stays the same. I then ask myself, 6 to the what power will give me 36, which will be 2, right? And we wrap that in parentheses, and outside the parentheses, we write down the original exponent, x minus 3. We then simplify further. On the left-hand side, we have 6 to the power of x minus 1 is equal to 6 to the power of 2 times x gives us 2x. 2 times negative 3 gives us negative 6. Now, we notice that we have the same bases, hence we set the exponents equal to each other. So I have x minus 1 is equal to 2x minus 6. I then move all the variables to the left-hand side. So minus 2x, minus 2x. On the left-hand side, we have 1x minus 2x, which will give us negative 1x. Minus 1 is equal to negative 6. We then add all the constants. We move all the constants to the right-hand side. So plus 1, plus 1. This will leave us with negative 1x is equal to negative 5. We then divide both sides by negative 1. And this will give us a final solution of x is equal to positive 5. Moving on to the next question. We have the following. So for this one, keep in mind that if you ever see a parentheses, you have to multiply. So we have 2 to the power of 2x is equal to, now whenever you multiply two exponential expressions like this, 2 to the power of 4 times 2 to the power of x, and the bases are the same, you add the exponents. So we have 2 to the power of 4 plus x. Now we have the same bases, hence we set the exponents equal to each other. So we have 2x is equal to 4 plus x. We move all the variables to the left-hand side, so we do minus 1x minus 1x. This will leave us with positive 1x is equal to positive 4, which means that the final solution is just simply x equals 4. Moving on to the next question, number 4. For this one, notice that the bases are not the same. The base right here is a 5. The base right here is 1 over 25. So we have to change the bases. In this case scenario, I go with 5 to be the base. So I have 5 to the power of 2x minus 10. That one does not change. Is equal to 5 to the power of what? Now, you want to aim for the denominator. So 5 to the what power gives you 25. In this case scenario, 5 to the second power will give us 25. But notice that we have a fraction. So it has to be a negative 2. So let's go ahead and wrap that. So anytime that you see a fraction, make that a negative exponent. So we have 5 to the negative 2. And there is no original exponent, so we can drop the parentheses. And now we see that the bases are the same, hence I can set the two exponents equal to each other. I have 2x minus 10 is equal to negative 2. I then move all the variables to the left and all the constants to the right. So plus 10 This will leave me with 2x is equal to positive 8. I then divide both sides by 2, and this will leave me with a final solution of x is equal to positive 4. Let's go ahead and box that. All right, moving on to the next question. Notice that we have a fraction right here for the base, 1 over 2, and a whole number 16. Now for this one, we also have to change the base. In this case scenario, I would say that 2 would be the best base that we can work with. So we're asking ourselves 2 to the what power will give us that denominator right here, okay? Well, it's going to be 2 to the first power. But because we have a fraction, it's going to be 2 to the negative 1. We're going to wrap that in parentheses because we do have an original exponent outside, the x minus 5. So we write down x minus 5 is equal to 2 to the power of what? Well, what will give us 16? 2 to the power of 4, correct? Now, there's no outside exponent, so we leave this one alone. We then rewrite this, and it turns into what? 2 to the power of what? Negative 1 times x will give us negative 1x. Negative 1 times negative 5 will give us positive 5 is equal to 2 to the positive 4. We then set the exponents equal to each other. We have negative 1x plus 5 is equal to positive 4. We then isolate for our variable by subtracting 5 on both sides. This will leave us with negative 1x is equal to negative 1. We then divide both sides by negative 1. And this will leave us with a final solution of x is equal to positive 1. Okay, moving on to the next question for number 6. We notice right away that we do not have the same basis. We have 1 over 49, and on this side we have a 7. So I would recommend that we go with the base of 7, okay? So we ask ourselves 7 to the what power will give us the denominator 49, okay? Well, it's going to be 2, but because we have a fraction, it's going to be negative 2 equals 7 to the power of x minus 4. That one does not change. Now we have the same basis, and we can set the exponents to be equal to each other. Hence, we have negative 2 is equal to positive x minus 4. We then move all the variables to the left-hand side, or you can keep it on that same side. In this case scenario, we do what? Plus 4 on both sides, plus 4. This is going to leave us with what? Positive 2 is equal to x, or essentially x is equal to positive 2 as the final solution. Okay, moving on to question number 7. So for number 7, notice that the base on the left-hand side is a 5, the base on the right-hand side is a 25. We want to end up with the same bases, so let's go ahead and do the smallest base, in this case 5. Since this one already has a base of 5, we keep the same exponent, 2x minus 8 is equal to 5 to the power of what? What will give us 25? Well, it's going to be 2. We wrap that in parentheses. We do have an original exponent x right there. And then we simplify further on the left-hand side. Nothing changes, so 2x minus 8 is equal to 5 to the power of what? 2 times x is going to give us 2x. Now that we have the same basis, we set the exponents equal to each other. So 2x minus 8 is equal to 2x. Then we do what? Well, we're going to go ahead and move all the exponents to the left-hand side. Oh, and my apologies. There was a little mistake right here. Let me change this to be a 3. There should be a 3 right here. Otherwise, it's not going to work out properly. Okay, so we have the 3 right there, 3x. So let's fix that right there. I forgot to change that on my end. So that's going to turn into a 6x. There we go. Same thing here. We have 6x. Okay, now we're going to move all the variables to the left-hand side. So I will do minus 6x minus 6x. This is going to give us negative 4x minus 8 is equal to 0. We then move all the constants to the right-hand side, so plus 8 plus 8. That's going to give us negative 4x is equal to positive 8. We then divide both sides by negative 4. And this will give us a final solution of x is equal to -2. Okay, now again, I just made a little mistake right here. I forgot to change this one to be a 3x. Okay, all right, let's go ahead and move on to the next one. For the next one, notice that the bases are not the same. We have a base of 3 here. We have a base of 1/27 right there. So we want to end up with what? The same base. So let's go ahead and try out 3. So we have 3 to the power of 5x plus 6. That one remains the same. We then have 3 to the power of what will give us 27? Well, it's going to be 3. But because I have a fraction, it's going to be -3. We then wrap that in parentheses to the power of x. We then simplify further.
Make sure you check your mailbox for the passes for today's tax period, anti-victimization.
Okay. We then set the exponents equal to each other.
Gym. You teachers should have passes in your box. Thank you.
Okay. We then move all the variables to the left-hand side, or all the variables to the right-hand side. It's up to you. In this case scenario, let's go ahead and move them all to the left-hand side, or excuse me, right-hand side. So minus 5x. Okay, and this will leave you with what? 6 is equal to -8x. We then divide both sides by -8. Okay, and this is going to give you a final solution of -2. Let's try -3/4 is equal to x, or essentially x is equal to -3/4. Okay, let's move on to the next question right here. And again, what we're looking for is for the same base. Right here we have an 8, right here we have a 16. Notice that these bases are not the same, but you have to keep in mind that if I work with the base of 8, right? 8 to the first power gives me 8, 8 to the second power gives me 64. So it's not going to work out. Nothing is going to work out with the base of 8, okay? So we're going to go ahead and use a different base. We're going to use the base of 2. If nothing works out, most likely it's going to be a base of 2. So we have 2 to the what power gives me 8? Well, it's going to be 3. So we wrap that in parentheses. We place the original exponent, x plus 2. We then have equals. We have 2 to the what power gives me 16? Well, it's going to be 4. Wrap that in parentheses. Outside, it's going to be an x. We then simplify further. We have 2 to the power of what? 3x plus 6 is equal to 2 to the power of 4x. We then set the exponents equal to each other. 3x plus 6 is equal to 4x. And again, you move all the variables to the left-hand side or to the right-hand side. It's up to you. Either format will work out. In this case scenario, let's go ahead and move all the variables to the right-hand side. So this is going to leave us with 6 is equal to 1x, or essentially x is equal to +6 for the final solution.